Max Tegmark, a cosmologist, proposed the mathematical universe hypothesis, MUH, which is a theory of everything in physics and cosmology. MUH posits that our external physical reality is a mathematical structure, and all mathematical structures that exist physically as well. This suggests that mathematical existence equals physical existence, and all structures complex enough to contain self-aware substructures will subjectively perceive themselves as existing in a physically real world, including human beings. This theory can be viewed as a form of Pythagoreanism or Platonism and a formal expression of ontic structural realism. Tegmark supports MUH by using Occam's razor to argue that it has no free parameters and is not observationally ruled out. He also augments the MUH with the Computable Universe hypothesis, CUH, that states the mathematical structure that is our external physical reality is defined by computable functions. Tegmark categorizes 4 levels of the multiverse hierarchy, worlds corresponding to different sets of initial conditions, physical constants, quantum branches, and different equations or mathematical structures. Andreas Albrecht of Imperial College in London called MUH a provocative solution to one of the central problems facing physics. Jürgen Schmidhuber argues on limitations of MUH, while Tegmark notes that a formalized approach of free parameter variations of physical dimensions, constants, and laws over all universes has not yet been constructed for the string theory landscape either. Tegmark has proposed a new hypothesis in response to the idea of a multiverse, suggesting that only fully decidable mathematical structures have physical existence. This theory limits the complexity of the multiverse and could possibly explain the simplicity of our universe. However, Tegmark notes that conventional theories in physics are Gödel undecidable, but the actual mathematical structure of our world could still be Gödel complete. He proposes the Computable Universe hypothesis, which only includes mathematical structures that are simple enough that Gödel's theorem does not require them to contain any undecidable or uncomputable theorems. Despite facing serious challenges, Tegmark argues that his theory is testable and will predict mathematical regularities in nature. The MUH is based on the belief that math is an external reality, but Jans and Green argue that math is a human construction and that reality should not depend on ideas of our making. The theme of the story is the nature and structure of mathematics. The author argues that there is no fixed structure or established way to address mathematical questions, as mathematics is constantly evolving. Tegmark responds by stating that mathematical structure is rigorously defined and that non-human mathematics only differs from our own because we are uncovering a different part of a consistent and unified picture, meaning math is converging in this sense. Don Page argues that there can only be one mathematical corpus, but Tegmark responds by stating that many structures can be unified. Alexander Vilenkin notes that typical mathematical structures should be cumbersome, which conflicts with the simplicity of theories describing our world. Tegmark's solution to this problem, assigning lower weights to complex structures, has been criticized as arbitrary and inconsistent with the set. The author emphasizes the need for a deeper understanding of the structure of mathematics and the limitations of Occam's razor as a final arbiter in deciding which theory to favor.